Right now, a signal that left Earth before you were born is still being heard 14 billion miles away by three dishes on the planet that know exactly where to listen. 1963, NASA faced a problem nobody had solved before. They'd sent probes to the moon. They'd sent them to Venus. But once those spacecraft left Earth orbit, they became ghosts traveling deeper into space, their signals growing fainter with every passing day. Engineers realized they needed something unprecedented. A network of listening posts positioned around the globe, all synchronized to catch whispers from the void. By March 1963, the first dish of what would become the Deep Space Network was completed near Goldstone, California. It was 85 feet across, enormous for its time, and its sole purpose was to maintain contact with spacecraft that NASA-owned engineers didn't yet know how far they could push. They were building the infrastructure for a future they could barely imagine. The network expanded methodically. By the early 1970s, three major complexes ringed the Earth: Goldstone in California, Madrid in Spain, and Canberra in Australia. This wasn't redundancy, it was necessity. As Earth rotated, one dish would hand off to the next, creating an unbroken listening post. A spacecraft could never disappear from human reach, no matter where it traveled. Then on September 5, 1977, something changed everything. Voyager 1 lifted off from Cape Canaveral. It was the fastest object humanity had ever launched, and it was heading toward the outer planets with a singular mission: photograph them, then keep going. Nobody, not even the engineers who built it, truly understood what would happen next. As Voyager 1 climbed away from Earth, its transmitter was broadcasting at just 20 watts, the power of a dim light bulb. By the time that signal reached the Deep Space Network dishes, it had been diluted across billions of miles of empty space. The power received was so minuscule it measured in billionths of a watt. Catching it required engineering that bordered on the miraculous. The dishes had to be pointed with precision measured in fractions of a degree. The signal had to be amplified through systems cooled to near absolute zero, because at those temperatures, the equipment's own electrical noise wouldn't drown out the spacecraft's whisper. Every component was engineered to detect the almost undetectable. Through the late 1970s and into the 1980s, the Deep Space Network did something remarkable. It stayed locked on a Voyager 1 as it flew past Jupiter, Saturn, Uranus, and Neptune. Each encounter was a milestone, each one transmitted back through that impossibly thin signal. But the engineers knew what was coming. Eventually, Voyager would leave the solar system entirely. On August 25, 1989, Voyager 2 made its final planetary encounter, a pass by Neptune that sent images back across nearly 3 billion miles. The Deep Space Network received them all, and then something shifted. The planets fell silent. Voyager had entered the void between stars, and the network had to adapt to a mission that would last not years but decades. What the engineers didn't know yet, what couldn't have been predicted in 1989, was that Voyager would keep transmitting for over 3 more decades. The spacecraft had been designed to last 5 years. It's now lasted nearly 50. The Deep Space Network had to evolve with it or lose contact forever. The signal from Voyager 1 is now so faint that each byte of data takes roughly 46 hours to receive. The spacecraft transmits its status, its measurements of the solar wind, its cosmic ray detectors, all crawling back at the speed of light, yet somehow still arriving. In 2023, NASA engineers announced that Voyager 1 trajectory had finally carried it beyond the heliopause, into true interstellar space. But here's what most people don't realize: keeping that connection alive required constant innovation. The dishes themselves were retrofitted with new receivers. The signal processing was completely rebuilt using digital technology that didn't exist when Voyager launched. The Deep Space Network wasn't just listening, it was continuously reinventing how to listen. Today, the Deep Space Network supports not just Voyager, but dozens of active spacecraft: Mars rovers, lunar orbiters, the James Webb Space Telescope. The same three complexes that were built in the 1960s are still the backbone of humanity's reach into space. But they're operating at a scale and sensitivity their designers could never have anticipated. The Voyager probes carry a golden record, a message from Earth encoded in analog grooves meant for whatever civilization might find them in the distant future. But before any alien intelligence could ever hear that record, it has to make one more journey, back through the interstellar darkness as a radio signal to the three dishes still listening on the planet it left behind. Voyager 1 is now over 24 billion kilometers from Earth. At that distance, even traveling at light speed, a signal takes more than 22 hours to arrive. The engineers who built the Deep Space Network in the 1960s couldn't have fathomed this timeline, yet they built it anyway, built it for a future they couldn't predict, to reach farther than they could measure. That's the untold story behind Voyager. It's not just a spacecraft that traveled farther than any object humanity ever made. It's proof that the infrastructure we build to reach into the unknown often becomes more important than the mission itself. The Deep Space Network was built to listen to the stars. It's still listening. and as long as Voyager keeps transmitting, it always will. The Deep Space Network represents something rare in human history. Infrastructure built not for profit, not for immediate return, but purely to extend human knowledge into the void. Every time engineers at Goldstone, Madrid, or Canberra lock onto that faint signal from Voyager, they're maintaining a connection that spans generations and reaching toward a future we're only beginning to understand. Subscribe so you don't miss the next untold story from humanity's greatest missions. There's always another layer beneath the surface.